So this lesson is about random, discrete, and continuous variables. This is really just a continuation from Unit 1 when we talked about discrete versus continuous variables. So, by the conclusion of this lesson, you'll be able to distinguish between discrete and continuous random variables. So, in any experiment of chance, the outcomes occur randomly and are so-called random variables. Um, so random variables are a quantity resulting from an experiment that by chance can assume different values. For example, if you roll a die, the random variable is, or the result of the random variable is 1, 2, 3, 4, 5, or 6. It can assume any one of those numbers and it's random. Um, so another example is the number of employees absent from the day shift on Monday. The number might be 0, 1, 2, or 3, but they are random. The number absent is the random variable. So number absent, or you know, number rolled would be the variable. The grade level, freshman, sophomore, junior, senior, of the members of the St. James High School varsity girls basketball team. Grade level is the random variable. So, it could be any one of the sophomore, junior, senior, freshmen. And so when I say random, I don't necessarily mean that, they're following the I don't necessarily mean that they're following classical probability rules where there's an equal chance of every single one of those occurring. However, what I mean is it really could be any one of those four, or any one of the possible outcomes that are listed. So one type of random variable, because there's two different types of random variables. There's discrete random variables, and there are continuous random variables. Just like in Unit 1, discrete random variables can only assume certain clearly separated values. For example, tossing a coin 3 times and counting the number of heads. It's either heads or it's tails. Um, it can't be heads 1.5 times and tails 1.5 times, I guess, unless it lands on its edge. But that, would be a no toss. It's either heads or tails. A bank counting the number of credit cards carried by a group of customers. They have a certain number of credit cards. They can't have half of a credit card. They either have a credit card or they don't. They either have 3 or they have 2 or they have 1 or they have more than that, but it's a whole number. Okay. So, for example, the Bank of the Carolinas counts the number of credit cards carried by a group of customers. The number carried is a discrete random variable. Okay, so right here we have a number of credit cards 0, 1, 2, 3, 4, or more. And then you've got the relative frequencies 0.3, 0.1, or sorry, 0.03, 0.1, 0.18, 0.21, 0.48, and those would also be the probabilities of those particular discrete random variables, if you were to generalize that. Okay, so continuous random variables is a random variable that can assume random variable that can assume an infinite number of values within a given range. It doesn't have to be a whole number. It doesn't have to have any sort of meaningful gap, and it's often the result of measuring something. Like, for instance, measuring the time of flights between Atlanta and Los Angeles. The different times of flights could be 4.67 hours, 5.13 hours, 6 hours, and so on. The annual snowfall in Milwaukee, Wisconsin is measured in inches. It could be 100 inches, 95, 96, 92. or 92.5, 96.3, but there could be increments between those inches, making it continuous. So that's the difference between continuous and discrete random. Once again, random doesn't mean necessarily classically random, that it's an equal chance of all of them. It just means that every one could possibly occur. So that is the difference between discrete and continuous. If you have any questions about that, post it on the discussion